That's what the extent of my Japanese, my apologies. So yeah, this is the NTLM version 1 reversion to NTLM with hashcat and the NTLM version 1 multi-tool by me. So a little bit about me. I'm the chief architect for X-Force, IBM's hacking team. I collect black badges to conferences, so I get free entry for life for a bunch of them. We don't care about that here. I'm a semi-retired member of Team Hashcat. I say semi-retired because I stopped competing in contests years ago and I just talk a lot now, so I don't do any actual real work. I'm a former sailplane pilot, special effects pyrotechnician, so fireworks, bishop of the Church of Wi-Fi, that's a whole different story, and I play a lot of Hacker Jeopardy. So that's enough about me, you're here for tools. So, Windows. The fundamental element of Windows password storage is you take a password and you basically UTF-16 little endian encode it. Basically that means you run it through Unicode. So, kanji, katanka, weird German characters, they all function properly fine in a password. You run it through MD4 and that stores it as an NT hash of 16 bytes. This is the fundamental piece of all Windows Active Directory security. If you know the NT password hash, you can authenticate as if you're the user without knowledge of the password. Doesn't matter whether it's 4 characters or 128 characters in, say, the case of a domain controller. So when you dump a system password, you'll see a user ID, the relative ID being user's ID in Active Directory, landman hash, which no one uses anymore because it's not 1999, and the NT hash. The reason why this gets important is there are a couple of different common password hash types used in Windows. You have the landman hash, which is hashcat mode 3000. If you see that in a domain, it's a whole different story. That's not what this talk is about, but it is DES-based. You have the NT hash, which is effectively MD4 UTF-16 little endian encoding. This is super fast, and this will be relevant here in about 6 slides, so bear with me. We're here to talk today about NTLM version 1, which is hashcat mode 5500, or now alternately mode 14,000, and it's also DES-based, and it's reversible to NTLM. And then you have the new, far more secure version, NTLM version 2, mode 5600. I mean, far more secure, just immune to this bug, but that's a whole different story, and it's HMAC MD5 based. So, the important part about this is NTLM version 1 challenge response looks like this. You're a client, you send a login request to a server, the server sends you back a challenge, you send back the response. Now why this is important is at no point in this password exchange does the actual clear text or the NTLM hash cross the wire. But we have a method now with hashcat to reverse that, which is we're going to next. So the initial steps of this is a client's going to send you an NTLM negotiate message. This basically sets up the parameters of the NTLM exchange. The server's going to create a challenge message packet. Basically says, hey, give me your password. And this contains an 8-byte random number, aka the server challenge. This gets used later in some DES calculations, but I'll show you a diagram. The client then encrypts that server challenge with the NT hash. So that NT hash basically gets converted into a DES key. The encrypted output of this is known as the challenge response. It's sent to the server in an authenticate message packet. The server forwards that to the domain controller, and domain controller sends back the response via a net logon. Fairly simple, nothing earth-shattering. This is all verbatim from the NTLM specification. Where this gets, the important part is how this response is generated. So that 8-byte client challenge gets null padded out to about 21 bytes. This forms the landman response, which I'll show you in the next slide. The 8-byte server challenge and then the 8-byte client challenge get combined together to basically form a session nonce. You then take an MD5 of that session nonce and you slice it at 8 bytes. This becomes the NTLM version 1 ESS hash. And yes, I know this is dry. You'll see in a second when it becomes undry, but this is very, very dry. That password then, so you basically take the, bear with me. You take the domain controller password, you UTF-16LE encode it, you MD4 it to get a 16-byte hash. That password hash is then null padded out to 21 bytes. Those 21 bytes are split into 3 parts. So you have one section, another section, another section. Those 3 parts are then converted into a DES key. Those DES key is then used to encrypt the NTLM version 1 ESS hash, giving you some 8-byte values. So effectively, the NTLM hash itself gets converted into DES keys. And that's the entire basis of the NTLM version 1 protocol. Well, it turns out that GPUs are really fast for cracking this. So we can actually convert these into hashcat compatible formats, and that's what allows you to then crack those DES keys and then reverse this to an NTLM hash. So those 8-byte values we're talking about here get converted to a 24-byte value known as the NT response. So the packet here we're talking about, this is direct output from a tool called Responder. Responder is a tool that we use to capture NTLM hashes and others on the network. So you get back the account. So in the case of a domain controller, you'll see here that the account name has a $sign at the end. That means it is a machine account hash. You then have a blank section because that was used back in the day but isn't. Normally the RID would sit there, the relative identifier in Active Directory. You'll see the domain, so evilmog in this case. We have the landman response, which is basically where the server challenge lives. So you'll see all those zeros at the end. Then you have the NT response, which is the results of that DES challenge, the DES encryption all concatenated together. Then the actual client challenge. So with just that packet, we have enough information to parse that into a hashcat compatible format. So what we're going to do is we're going to take a look at this big eye chart here. So going back to this, we have the domain controller password. And the domain controller password in Active Directory, if it's configured correctly, will be 128 characters, and it will change every 30 days. So there's no way any machine out there can go crack that password. But the good news is we don't need to. We just need to know the contents of the NTLM hash so we can later DC-sync a system. So that gets, little endian encoded, run through MD4, and that becomes hashcat mode 1000. From there, we then go take the client challenges. That becomes the plain text. We split that NTLM hash up into 3 sections, convert those into DES keys, setting the parity bit to 1, and then we encrypt that challenge to create ciphertext. You can concatenate those 3 together, and that became this little big long string there, the NTLM hash. That's the output of the result here. So this is the initial client keys, these 2 combined together. That's the DES key. These are the DES keys, this is the ciphertext, or the plain text. Note comes effectively ciphertext. So we know how to effectively crack these hashes. So with that, we use actual values. And again, this is an eye chart from earlier. So another cool part is this is actually a weakness. Because we're going from a 21-byte null padded, we only have enough key material to fill the boxes for these 2 keys. So you're really only cracking 2 DES keys. This DES key has just parity bits and a little portion of it, so it can be cracked with a CPU in about 30 seconds. These take about 70 hours. But you see the response has our outputs that then get concatenated together. This gets useful for our demo shortly. So, your attack technique in this is we're going to take responder. We're going to listen on the network for attacks. In this case, I'm specifying the network interface is Ethernet 0. We've forced authentication. Then we use a tool called coercer. So, people in here familiar with coerced authentication? Like a print spooler or EFS coerce? For those that aren't, there are a number of protocols in Windows whereby if I connect to a system, such as the print spooler, I can say, I need you to send me your printer details. Well, that packet coming back to me, I can challenge the domain controller in this case to say, please send me your authentication. I'm a server, please connect to me. It'll do a challenge response and send me an NTLM version 1 packet. What coercer does is it uses a number of different techniques such as EFS, encrypting file systems, DFS, print spooler. There's a list. It just spams them at the target in this case, in which case is a domain controller. It will then send it back its hash. So in this case, DC1-mog, all that garbage here. So we then take that and we run it through a tool. So in this case, that challenge, that 1122334455667788, that's the challenge set by the attacker, me, but it still needs to be combined in with the client's challenge, which is why for a long time people said, there's a tool called crack.sh, if people are familiar with that. It was an FPGA-based cracking system. You get your results back from it instantly because of its rainbow tables if you use that challenge without ESS being engaged. But if ESS was engaged, it would change the challenge so that rainbow table was ineffective. But now that we can use hashcat, nobody really cares. That and crack.sh hasn't worked in years. So, you git clone down my tool, go to github.com/evilmog, and there's a QR code at the end that actually displays what this is, so you don't have to write down my chicken scratch. But you git clone down the tool, you run Python 3 NTLMv1-multi, tac NTLM, and you give it the hash. The tool will then output what you put into hashcat, including the commands to actually execute. So you no longer have to manually format the hashes. This just create the candidate file, run hashcat using either hashtopless, run it manually, sit it in the cloud, etc. In the case of 2L40Ss on IBM Cloud, which are RTX 4090 equivalents, it takes about 72 hours, maximum. So, you then, once you have the results of that, you'll clone down the hashcat utilities. In this case, hashcat or github.com/hashcat, hashcat utils. You then pop into the source directory, you run make. Now, the reason why you have to do this is you have to convert the hashcat des keys they gave you back into NTLM keys by stripping out all the parity bits in the des key. So that's what's gonna, so you run the des key to NTLM perl or .pl file, give it portion 1 you cracked, it outputs the results. You then give it portion 2, does the same thing. Then there's a tool called CT3 to NTLM that does the last des key portion in CPU for you, because otherwise that's the final piece, and it's a really short CPU crack. Then from there, you just concatenate the 3 files together. Or the 3 pieces. So you have the first half, which is of the NTLM, you have the second piece and the third piece. They each run netexec. And what you're doing is you're telling the domain controller, hey, hello fellow domain controller, I'm a domain controller, here is my key. It then replicates to you the entire hash format or set of hashes back to you. You then crack the hashes and profit. Relatively simple. So that's the actual brief explanation. The rest of this is all demo. So we'll go see how this actually works. But to make your life easy, I promise this is not phishing. I would not hack you at a hacking conference. I mean, maybe I would, but There is a resource directory under there. When you clone it down, it's resources. And in there, there's an agenda and steps.txt. It goes through step by step how all this actually runs, because I even forget how it executes. Also, I do update the README, so if there's a problem in the documentation, I update the README. And if anyone here is really good with both English and Japanese, and you want to submit a Japanese translation, please send me a pull request. I'll happily merge it into the tool. I want this to be available in as many languages as possible, because it's 2024, and if you still have NTLM version 1 enabled in your environment, that's bad. So I should probably preface this. There is a setting in GPO right now. It's called Landman Compatibility Level, or LM Compatibility Level. This only works if it's set to 2 or below, which since Server 2008, it's been set to 5. So this really only affects if you've got an ancient domain that was built sometime back in the Stone Age, which is all of us. So check your GPO settings. It's different for both domain controllers and clients. So 3 and above, you're largely safe. In a transition mode, you want to switch it to 3, and then after everything's been transitioned, then go to 5. Otherwise, you'll have lockouts in your environment, and no one likes recovering from locked out computer accounts. They're a pain to troubleshoot. So I digressed in that piece. Now we do a live demo and see if I have sacrificed my intern to the demo gods correctly. So feel free to laugh when things break, and then I'll happily go back over pieces I've glossed over. So on that, let's see if I can do this one-handed. All right, so step one, I'm going to clear the responder database. Good, there's nothing there. That means I'm not cheating. I mean, I probably am, but that's all right. We're going to specify a responder. Now there are two modes on this I'm going to demonstrate. Just so you can see the two types of hashes you're referring to. So this is without ESS disabled. So I've turned on responder. Actually, I'll talk this through. So again, specify the interface, specify -fp. Now we're going to go up to a tool called coercer. So the syntax of coercer is I type coerce, a coercer in coerce mode. I give it a username, so in this case user1, and because I'm really secure, my password of password, exclamation mark, because we don't believe in secure passwords here. You specify the domain. Now the reason why you need to specify a password in coercer for a regular user account is some of the techniques require a regular user to force the DC to authenticate to you. Other techniques like print spooler can be done unauthenticated. So the unauthenticated ones like the print spooler, you can just use Dementor, there's a few other tools out there, just Coercer has them all wrapped in. So I have now typed my magic. You specify -t for your target, so my target in this case is the domain controller, which is 46.5. The listener is your IP as the attacker, so that's the 46.10. And then you just listen. So I'm going to, there we go. So you'll see on here I got a hash out. So this is what it looks like with ESS enabled. If I want to disable ESS, we're going to see if we can force this thing to authenticate again. RM. I'm doing this not bad, one-handed. Yes, there's jokes there, I'm not the one to make them. So you'll see here the difference is the first part didn't have a whole bunch of zeros. That's because it's using the client hash only and not the server hash. That's a hardening step. This is a step that was implemented a little later in the NTLM version 1 lifecycle. And this is what was defeating crack.sh until they added in disable ESS mode about a year or two ago into Coercer itself, or Responder, might have been 2 years, yeah. Anyways, I digress. The important part is we now need to copy this. And the reason is we need to pop this into our tool. So I'm going to go into opt, my NTLM version 1 multi tool. We're going to run Python 3 NTLMv1.py NTLM. All right, cool. So the output of this tool looks like this. It'll add some debugging pieces because, quite frankly, I was lazy during my build. It'll output your host name, username, your challenge, your landman response, your NT response, and the 3 ciphertext pieces. And then, of course, this lovely command you just copy later on because I believe in copy and paste. The important part is I copied this little section. And to make sure I haven't cheated, we're going to just echo that. So now I've made a hashcat compatible file. So because I don't have 70 hours and you don't have a time machine, I mean we do, but I've pre-cracked these hashes, so I'm lazy, but we go to hashcat-m mode 14,000. Normally you'd specify attack mode 3, the des character set, hex mode, your hash, and then it outputs the attack format. In my case, because we are, again, being lazy, I'm just using a pre-calculated des, or a pre-calculated candidate file. Yeah, well then. Did I? See, this is the joys of a live demo. I'm pretty sure I cracked this, but let's go over see what my des.cand file is. I may have deleted it. History, fgrep, des.cand. Is there a note that results are, haha. So, why this is important is, there's actually also a tool in the NTLMv1-multi tool, if you want to do testing, that will convert an NTLM hash into des. So if we go to Python, come on, Python 3 NTLM-2, there we go. So if I give it an arbitrary NTLM hash, it'll tell me how to create these candidate files for cheating. So I've made a reverse, so if you already know someone's hash to make sure my tool's working for demo purposes. You wouldn't use this in an attack scenario, but you use this for demoing things out in a lab. So I've created the hash, so we're gonna go back to hashcat. And we're gonna sit here and wait. Oh look, it already knows what my hashes are. Apparently, my time machine works. So the important part is these keys from your hashcat candidate file, or your pot file, are not directly NTLM keys. They're des keys. You need to convert them. So we're gonna go pop into hashcat utilities. Hashcat utils. And then we are going to go CD source. And then we are going to go to, it's not CT3, it's a des key. There we go. So portion 1. And then we're going to go scroll up to grab the second piece, which is portion 2. And that converts the first bits of it. And then we're going to scroll all the way up to my middle magical multi-tool. We're going to copy and paste this. So you'll see here we now basically have 3 parts of a key. So the NT hash is going to equal part 1. We're going to copy part 2. We are going to copy part 3. I'm going to steal that now for the entire piece. Command C, Control C, and then we use the tool called netexec. Clear. Net SMB192.168.46.5. We're going to specify the domain controller's username, which in this case is DC1, because I am not imaginative. There we go. We're going to specify the hash. And we'll see here that this hash actually works. Now, the cool part is you don't see a pwned, you don't see anything else like that, but if you go NTDS DRS UAPI, which means using the Directory Replication Services API, yeah, I believe in living dangerously. Congratulations, I now have the entire domain hashes. So this is how, if a domain controller is enabled for NTLM version 1, if you have a time machine over 70 hours and the ability to grab the hash, you now have the entire domain. The cool part about this, and this is not actually demoed in here, people here familiar with wireless? You all have phones, I assume? Wireless, there's a protocol called PEEP MSChap-v2, basically password hash authentication over a radius server. Exact same protocol. There's a tool called EAP Hammer that will allow you to capture hashes over the network. You can capture machine hashes or network hashes, and then use this exact same technique on MSChap-v2 hashes. The cool part about this, and this is something few people know, if you have the NTLM hash, you can actually authenticate to a wireless network with just the hash and not the password in PEEP MSChap-v2 mode, which means wireless hacking just got easier if you can get a hash out via EPAMR. So this is not just based off legacy Windows protocols that should be turned off. All of a sudden now your Windows protocols are basically broken. So with that, I have all the time in the world for questions, because A, I talk fast, and B, this was a really cool demo. So questions around the room. Or are you all just asleep and I knocked you all out? And does anybody need anything rephrased, translated, or otherwise re-reviewed? Cool, so anyone want to see the link to the multi-tool again, or do you need it, or everyone managed to get that copied down? Perfect. So feel free to answer questions. I answer pull requests, documentation clarification. I accept translations into Japanese or any other language you want this translated to. Who would have ever thought a 30-line Python script could be so deadly on a network when combined with hashcat? And that's it. Thank you for, oh yeah.
Like, could I ask you
Sure.
about the stealth? If it's part of the, I guess, let's say an assignment where we run netexec from the machine. I think that's pretty easy to spot. So like, yeah, I guess running it from the main controller would help, but yeah.
Yeah, there's no real stealth. I mean, so here's the thing. If you crack the NTLM version 1 hash, you have to rely on standard OPSEC. I'm using netexec in this case for pure demo purposes. You can also use, if you don't want to go to using netexec, and you have the knowledge of an NTLM hash, you can always just make your own Kerberos tickets based off the knowledge of that. You can create a silver ticket, was the other way we used to do this. There's a few other methods. If you manage to get, you can't really golden ticket it because you can't get the, you can get the Kerberos ticket out, but that's one way. But I'd say silver ticket's the stealthiest route. And silver tickets don't have a pack, so that shouldn't show up in any EDR tooling. You can also do, let's say, a resource-based constrained delegation attack using that hash, or you could go talk to, say, a certificate authority and then go get a hash that way. But for this case, I used to use netexec because, well, I'm a hacker and I'm lazy.
Yeah, I get it. Thank you.
Yeah, no worries. Any other questions? No question is too taboo. Except for what kind of sake I like. That's easy. Jumai Daiginjo. No, well, thank you all very much for showing up for that talk. That was incredibly quick. I apologize for making it, half an hour or less. I'm happy to re-clarify any of the math or the sections if anyone wants a more in-depth dive through pieces, because I know that was a fast run through. So does anybody want to see any of the parts of this tool again, or any parts of that demo or the slides? Cool, well, thank you all for coming and being awake through my talk. I know crypto can be dry. With that, I'll hand it off to my monitor.